Okay, so chapter 5 is all about systems of equations. It's all about systems of equations. And our system of equations, you can see here our definition. It's a set of two or more linear equations with the same variables. It says in the same variables, with the same variables means the same thing. So two or more linear equations, which means we can put into y equals mx plus b. All right, we've talked all about linear equations. So we've got two or more equations with the same variables. They both have x, y here. So there's your example. You got two equations, they both have an x, both have a y. That is a system of equations. There's more than one equation. What we're going to do for the next few sections, the next 3 specifically before the quiz, is we are going to talk about solving the system of linear equations. And we talk about a solution of the system, right? A solution to the system is an ordered pair that works for both equations, for both of the equations, right? We sort of looked at this with the warm-up, right? The warm-up today, we looked at just one equation with an ordered pair, and we said, is this a solution to this one equation? Very similar. Now they're going to give you a system. They're going to give you 2 equations. So they're going to give you this system, and they're going to say, all right, here is our ordered pair. Is this a solution to the system? So we're going to do the same thing we did in the warm-up. But now, if it's going to be a solution, it's got to work for both of the equations, not just one. It's got to work for both. Okay, so I want you to take a second. Go ahead, plug those in. Keep it to yourself. Think to yourself. We can either do it in our head, on paper, calculator, whatever you need to. Let's see if this is a solution to this system. All right, so if we look at it, the solution to the system, right? We're going to plug that in, make sure the first one goes in for x, second one goes in for y. Of course, the top one works. 2 plus 5 is 7. We know that. So we got to check the bottom one. We plug that 2 in here. 2 times 2 is 4. I plug the 5 in here. Negative 3 times 5 is a negative 15. So I have 4 minus 15. 4 minus 15 is negative 11. This is a solution. This is a solution to that system. It works for both of them. Right? So that would be a solution. What if they gave you, let's say, the 0.34? Well, again, I know it works for the top one. 3 plus 4 is 7. I got to check the bottom one, though. 2 times 3 is 6. Minus 12. 6 minus 12 is negative 6, not negative 11. So this one does not work. It is not a system. So for it to be a solution, it's got to work for both of them, not just one. It's got to work for both of them. So if you're doing these questions on the homework, it's going to be a yes or no question. As soon as you find one that doesn't work, your answer is no. Right? So if I take 3, 4, I plug it in the bottom one first, I know that it doesn't work. I don't even have to try the top one, right? But if it does work, then I have to try it. I have to make sure they both work for it to be a solution. Okay, so that's what we're looking at here. Is it a solution to the system? So if we think about this, we think about these lines. Okay, that top one, let's say it's a line that looks like this. Okay, I don't have the full graph on there yet, but it's a graph that looks like this. Now, all of these points along this line are going to be solutions to that top equation, right? Every single ordered pair that I can find on that line will work here. 0, 7, 1, 6, 2, 5, 3, 4, right? All of those ordered pairs are going to work. They're going to be part of that line. I can do the same thing with this one, right? On this one, if I have that line, I'm going to have a whole bunch of ordered pairs that are going to work for that bottom one. But there's only one ordered pair that those two lines are going to share. And that's the solution. So when we talk about a solution of a system of linear equations, there's only one solution. There's only one ordered pair that's going to work in both of those equations. Okay, there's only one. So our goal beyond just does this work, does this work, does this work, that's one type of question that you're going to see, right? But beyond that, it's going to be, what is that one point? Okay, we're going to have to find that one point, and that's what our next three sections are all about. Finding that point where those two equations cross. Okay, that's what we're looking at. Again, if you have questions, make sure we're typing them in, okay, so that I can answer those. Okay, all right, good deal. So we are going to talk about how do we find that solution? How do we find that point? And today I said, with our I can statement, we said we are solving by graphing. So we are graphing today. If we were here, we would be using graph paper for the homework. We're not here. So if you have graph paper, great. You can use that on the homework. If not, you're just going to use line paper. But we are graphing a little bit today. So let's talk about graphing. Because you know just about everything you need to be able to do this. There's nothing really new. I'm going to point out a couple things that we got to make sure of and we got to be careful of and all of that. There's nothing new here. You don't have to copy this stuff down. I'm going to talk through it, but you don't have to copy it down. To solve a system of linear equations by graphing, step one is to graph the equations. We're going to graph the two lines. Okay, we're graphing both of the lines on the same coordinate plane, on the same graph. We're going to graph both lines. Then it says estimate the point of intersection. I don't like that word estimate because we're not going to estimate anything. Estimate makes it seem like we're guessing. We're not guessing. We're going to find exact answers here by graphing. So we're not estimating. We're finding the point of intersection. We're finding the exact point where these two cross. And then step three says check the point. So check our point of intersection by plugging it back in. So that just means we can check our answers. We can make sure if we are correct or not. We can take a look at that. So we'll talk about that as well. So we are solving by graphing, which means we have to graph, which means I'm going to put graph paper up on the board here. You probably don't have graph paper in front of you, and that's okay. In your notes, let's go ahead and make a graph. Let's go 5 in every direction. Go ahead and create that graph, 5 in every direction. What if the intercept is not on a point? In terms of the ones that you're going to see today for graphing, it will be on a point. When it's not specifically on a point, that's what tomorrow and Wednesday are going to be all about. Let's go 5 in every direction here. Hopefully your graph turns out better than mine. That wasn't very straight. Give you a few seconds here, create that graph, 5 in every direction. We'll talk about how to solve this system by graphing. So here's the system that we're gonna graph. We're gonna solve here. Y is equal to negative 2x plus 5. And we're going to look at y is equal to 4x minus 1. So there's our system that we're going to look at. I got to get some better markers for this, but I'll do what I can to make it so that we can read it. So we got y is equal to negative 2x plus 5, y is equal to 4x minus 1. So all we have to do here is we got to graph both of them. We're going to graph both equations. So that top one, if I graph that top one, it's y equals mx plus b. So I've got that 5 as my intercept. I got a slope of negative 2. That's negative 2 over 1. That means from that point, from that intercept, I'm going down 2 over 1. And there's my line. Okay, so I graph the first one. Y equals mx plus b. Then I got to graph the second one. So I've got an intercept of negative 1. My slope is 4. That's 4 over 1. So from there, from that intercept, I go up 1, 2, 3, 4. over 1. Hey, it's the same point. Look at that. And since that's the same point, that's where they cross. That's my answer. That's my solution. Right? So this whole thing, the graphing itself is not the answer. Okay? The graphing is the work to get to the answer. The answer is that ordered pair. The answer is the point 1, 3. That's my answer. So when you check your answers today, that's what the answer key is going to show, is that ordered pair. It's not going to show the graph. It's going to show the ordered pair. Okay. So that is our point of intersection. That is the solution. That's the one point that these two equations have in common. So one point that they share. I could take that 1, 3, I could plug it back into both of these to double check, to make sure that that is the point that works. If I plug that in, I plug a 1 and a 3. That's -2 plus 5 is 3. That works. 4 minus 1 is 3. That works. They both work. Right? That is the one point that they have in common. So we graph it, we see where they cross, that's our answer. Okay? That's the big idea behind this. Graph it, see where they cross. Okay? All right. So let's talk, though, about a couple things. First of all, let's say that the equation is not in y equals mx plus b. We have to get it into y equals mx plus b first. Okay? You're going to want all of your equations, both of your equations, to be y equals mx plus b before you start graphing. Okay? Get it there so that we can plot that intercept, we can use that slope, so we can find the exact line. Okay? We'll put it in y equals mx plus b first. All right. Let's, the other thing that I want to talk about, let's say that we have, I'm going to draw the lines first, and then I'm going to write the equations out. I'm going to do things a little backward here. Well, let's say that I have these two lines. So this would be y is equal to -1/2 x plus 4. And then this would be y is equal to x minus 2. So I've got those two equations here. So I've got these two equations. I graphed them both, but they don't cross. Well, how I have them drawn, they don't cross, right? So here's what we can't do. Okay, here's what we should not do. And I see it all the time. I see people graph this and say, well, I need to see where those cross. Well, let's see, this and this, they cross about right there. There's my answer. All right, they look at that and they go, all right, there's my answer. That's not it. Okay, you can't just draw a random curve and call it a line. Or you can't just eyeball it and say, yeah, this is pretty good. Remember, our slope is constant throughout. It's a constant rate of change for each line, which means the slope isn't just up 1 over 1 here, it's up 1 over 1 throughout the whole entire line. So what we're going to do when we graph, if it doesn't cross right away, that's okay. Continue that slope. So this is up 1 over 1. I'm going to keep going up 1 over 1. I'm going to extend that line. That way I know for sure that these are points that are on this line. I'm going to do the same thing up here. My slope is down 1 over 2. I'm going to do it again. Down 1 over 2. Now I found for sure that point where they cross. So we are going to continue our slope until we find where they cross. You have to continue that slope. Don't just give up after up and over once or down and over once. Keep going until you find where they cross. They're always going to cross. They're always going to cross today. You just have to find that point. Okay? All right. Good deal. And again, I could plug that back in and it would work. Always check your answers. We're going to always check our answers here. All right. Again, if you have questions, type them in. I'm checking that chat as we go. Let's say, for the next thing, or if you have a question, you can just chime in too. That's fine. Let's say now that I'm not going to write up the equations for this one, but let's say that I have this line and this line. So I graph those two, and they look like this. They don't cross. If I continue off this way, they're not going to cross. But I told you, every line is going to cross today. That just means we have to go backwards. We have to go to the left. All right? We have to go to the left here because they're going to cross somewhere over here. So you just got to use your slope the other way. So instead of going down 1 over 2, think of that as up 1 and backwards 2. Right? Flip the signs. So instead of going down 1 over 2, go up 1 and backwards 2 to get that next point. Up 1 and backwards 2 to get that next point. Right here, instead of going up 1 over 2, go down 1 back 2. Down 1 back 2 until we find that point where they're actually going to cross. So they are going to cross, just sometimes we have to go left. And that's okay. Just follow that line. Make sure you're following that line until they cross. Okay. All right. Good deal. I'm going to have you do one, and then we'll discuss it, and then we'll be done. We got 2x plus y is equal to 5. We got 3x minus 2y is equal to 4. Remember, first thing you have to do is you got to put those into y equals mx plus b. So put those into y equals mx plus b. Draw them on your graph. If you need to make a new graph, that's fine. Let's see where they cross, and then we'll talk about it. I'll give you a couple minutes here. I'll be quiet so you can learn. Got the two equations in y equals mx plus b up there for you, just in case we're confused on that. We got to get those right, otherwise graphing does us no good. All right, let's look at graphing it. The top one, right? First of all, we subtracted the 2x, so we get y is equal to negative 2x plus 5. So our intercept's at 5. Negative 2 is our slope, so that's down 2 over 1. So down 2 over 1. And what I can do is I can do that a couple times. I don't have to go back and do it. If I'm going to graph it right away, down 2 over 1, I'm going to do that a few times. Just so I have that extended, I don't have to go back and extend it later. Then that bottom one, all right, I subtracted 3x. Make sure you still have a negative 2y there, right? That negative belongs to the 2. And then I divide everything by -2. And negative divided by negative is a positive 3/2. So 3/2 x minus 2. So I'm at -2 here, up 3 over 2. So up 1, 2, 3 over 2. So there's where I cross. So my answer here would be 2, 1 for my solution. Okay. Good deal. All right. So for the homework tonight, the homework is not an assignment on big ideas, okay, like we typically have. It's going to be slightly different. So it's going to be out of the book, just like our quiz reviews are. Okay, it's out of the book. If you go on to Schoology and you look at the post, the update for today, on the homework, it has the page number and it has the question numbers that you have to do. Okay, I had like 4 people chime back in first hour to ask what questions they had to do. It's on the Schoology update. It has the page number, it's got the question numbers that you have to do. Do those on a separate piece of paper. Okay, if you have graph paper, I'd use that. If you don't, line paper's fine. Just try to create good graphs for yourself. Okay, you're going to do it on there. You're going to take a picture and submit it. The reason we're doing this is because if it's on big ideas, it's multiple choice, and you don't practice graphing. And that's what all this is about, is graphing. So you got to do it on a separate piece of paper. Okay, submit that picture, and then you'll be all set. Okay, if you have any missing assignments, make sure you're submitting those. Email me to let me know that you submitted anything late so that I can go and change that right away. Okay. Otherwise, you can log off, sign back in if you have questions, and then I'll see you tomorrow.